Eureka!
This unit is divided into 3 programs. The program you're about to see is on atoms. This will be followed by electrons. And the 3rd and final program in this unit will be on conduction itself. But our story begins with atoms. We know that everything is made up of molecules. That tree, the plastic cup, the magnifying glass, this piece of lead pipe. Even you are made up of molecules. Does that mean that molecules are all the same? In that case, why do glass cups break when you drop them, when plastic ones don't? On the other hand, why can't you see through a magnifying glass made of pink plastic? Or chop down an aluminum tree with a rubber axe? If all these things were made of identical molecules, how could they all be so different? If everything around you were constructed with exactly the same building blocks, it'd be like living in a world of Lego. So molecules can't all be the same, can they? What are molecules made of anyway? We know that they're little lumps, but little lumps of what? Of course, there's no magnifying glass powerful enough to let you see molecules. They're much too small for that. But scientists now know that if by some miracle you could look closely enough at a typical molecule in plastic, for instance, you would see that it isn't a solid lump at all, but a lump of thousands of tiny round things all jiggling about together like a bunch of grapes going bananas. Scientists call these tiny round things atoms. But notice that not all the atoms are alike. Some are big and some are small. Some have a lot of mass and some have very little mass. Now let's look at a typical molecule in glass. It's completely different from a molecule in plastic. There are only 3 atoms instead of thousands. And therefore, a molecule in glass is much, much smaller. And that's why something made of glass can behave so differently from something made of plastic. Let's zero in on something made of metal now. The head of an axe, let's say. And see what a molecule of iron looks like. Ooh, that's strange. The whole axe head seems to be just one giant molecule, because the atoms aren't bunched together in lumps at all. They're all independent of each other. In a sense, there are no molecules in iron, only separate individual atoms. All of them the same size and all arranged in a square-shaped latticework. Now let's look at something made of another sort of metal, a lead pipe, for example. In lead, the atoms are also all the same size, but they're much larger than in iron. And they're more tightly packed within their latticework. But they're still separate, individual atoms. So, strictly speaking, there are no molecules in lead either. In fact, there are no molecules in any pure metals. Iron, lead, aluminum, copper, silver, gold, you name it. They all consist of separate, individual atoms. But all substances in all 3 states of matter, solid, liquid, and gas, are made up of different combinations of atoms of different sizes and masses. Either arranged separately, as in all pure metals, or bunched together into molecules, as in most common nonmetals, liquids, and gases. So next time you chop up some wood, or feel the weight of a lead pipe, or drop an unbreakable plastic cup, remember the enormous variety of different combinations of atoms that makes all this possible. And be thankful you don't live in a world of Lego.